Hello everyone. In this video session, we are going to study second application of operational amplifier, that is Schmitt trigger. Operational amplifiers are differential amplifiers which can amplify the difference of two signals based on the amplified factor, and we can get the output. This particular property of operational amplifier is used to compare two voltages in Schmitt trigger circuit. Schmitt trigger, it is a fast operating voltage level detector. In Schmitt trigger, there are of two types: inverting Schmitt trigger and non-inverting Schmitt trigger. Here, the input voltage Vin is applied to the inverting input terminal, and the feedback voltage goes to the non-inverting terminal. Means the circuit uses positive voltage feedback. We will see the working of it with reference to the waveform. When the input voltage crosses the positive peak the output of the Schmitt trigger circuit will come to 0 or goes to minus V saturation, and it will remain at the minus V saturation until the input voltage crosses the negative value. Once it crosses the negative value, the output will go to the positive V saturation. This particular phenomenon repeats. The positive reference which we have set is called upper trigger point, and negative peak reference which we have set is called lower trigger point. The difference between the upper trigger point and lower trigger point gives us V hysteresis. Non-inverting Schmitt trigger. Non-inverting terminal of this circuit is given with input voltage, and reference voltage is also given to the non-inverting terminal only, and the inverting terminal is permanently grounded here. Here the input voltage is get compared with reference voltage. Now we will see with respect to waveform inverting Schmitt trigger working. Initially we assume that the output is in the negative V saturation. Then the feedback voltage is also negative. This feedback voltage will not hold the output in negative saturation until the input voltage becomes positive enough to make voltage positive. When Vin becomes positive and its magnitude becomes greater than R2 by R1 into V saturation, then output switches to positive V saturation. Therefore, upper trigger point at which output switches to positive V saturation is given by R2 V saturation by R1. When Vin becomes negative and its magnitude becomes greater than R2 by R1 into V saturation, then output switches to minus V saturation. Therefore, the lower trigger point at which output switches minus V saturation is given by minus R2 V saturation by R1. The difference between upper trigger point and lower trigger point gives us V hysteresis. Now we will see the applications of Schmitt trigger. Schmitt trigger is used in many applications where level needs to be sensed. Hysteresis is used to reduce the multiple transitions that can occur around digital to analog conversion, level detection, line reception. Thank you.